Hey everybody, we're going to get started. Today we're doing 13.7. I hope you watched the videos. Meet my new dog Lunar. That's him right there with my wife Angie. He's already a little shit. I woke up to getting my hair chewed on. So 13.7 is on using gradients to find tangent planes. Just like when we were doing the gradient of f dotted with u equal 0 showed level curves. To get a level curve and not to have a dot product of 0, the gradient of f had to be normal to the curve. So there's the curve C. We have some tangent vector u right there. And to get it to be a dot product of 0, it had to be orthogonal or normal. The same applies to surfaces. So on a surface, we could have any curve going through a point, and as long as we have the equation set up to be like a level surface, where the surface is the same height everywhere along that curve, we still need the dot product to equal 0, which means that the gradient of f has to be normal to the surface. So in 3 dimensions, the gradient of f is normal to the surface. In 2 dimensions, it's normal to the curve. So let me bring that back down.
Thank you.
And the next 2 days will be on 13.8, which is on finding maxima and minima. I know you guys did this in Calc 1 for one-dimensional surfaces. Now we're going to expand that to regions, an area.
Yeah, this whole part.
So if you didn't watch the videos, and shame on you if you did not, shame.
I dislike them. I watched the videos and then forgot everything the next day.
The idea is to take some notes and see what things you have questions about.
That's what I did right here. I shouldn't. That's what we.
And the gradient of f is evaluated at p.
Yeah, I know. Yeah, okay. I see.
can't tell me you do test videos and then watch everybody else's videos. It's just not right. Sebastian's trying to get an F linking videos to other professors. A professor called Dave too at that. Where's Sebastian? So what do we have for the gradient of F? What's the partial derivative with respect to X? If we've forgotten what gradient is,
Oh, no. Never heard of. Whatever that.
so what is the gradient of F? Just variables at first. We can do variables first. What's the variables?
X, Y, I guess.
No.
So that should be what you got for the gradient of F at that point. So what we're doing is we're taking that -6, 9, and 16, and we're dotting it with the X minus X naught, which would be X plus 3, Y minus 1, and Z plus 2. And that should equal 0. Because we're having the gradient of F times the line. So we've got -6 times X plus 3 plus 9 times Y minus 1 plus 16 times Z plus 2. We've got -6X plus 9Y plus 16Z. I see a -18, a -9, and a +32. So what is that? +5. So if we add that up, +5, we move it, and that equals 0. So if we move it to the other side, we'll just have equals -5.
Which one? We're talking about the 18, 9, and 32.
No, we're using -6x plus times x plus 3 and then -6.
Use that's the gradient of a point. Wait,
It's the gradient of f at the point. So we're plugging in -3, 1, and -2 into the gradient right here.
Almost the last second, third to last line.
I can
Oh,
hear
good.
Lawrence talking, but not what he said.
I said, the third to last line, where are you getting those x, y, and z values? Not the x naught, y naught, z naught, the other like.
I'm
the
doing like these
Yeah,
x
the
minus -3. I'm using the point P.
yeah, but then how did you simplify it down to the next line? Like, where did the points come from?
you just expanded it
I'm
out. You just-
distributing,
Oh,
but I
okay.
didn't do the constants till the end. I put all the variables first, and then I put the constants
I see.
together.
I see.
yes.
Do you want us to write it out in its expanded form, or would you be all right if we kept it like the second line in red? Would you be all right if we kept it like that, or do you want us to expand it?
You should put it like that. Yeah, I need to give you a chance to fuck up on your algebra.
Yeah.
Show me that you deserve to pass a calculus 3 class. Show me you can do some algebra.
Nice. Don't be skipping those steps.
Right? All right, so we wanted the tangent or the parametric equations. So the normal line is this -6, 9, and 16. This is the normal line. So if we wanted to turn that into parameters, we would do x equals x naught plus at, y equals y naught plus bt, z equals z naught plus ct. A, B, and these are ABC. Normal line is ABC in this case. X naught, Y naught, Z naught was our initial points. So -3 minus 6t. So I got the -6 from here and the -3 from the point. And then we've got 1 plus 9t and -2 plus 16t. So those would be our parametric equations for that normal line. So now we have new ways to get tangent planes. We did it before and it was a lot more of a pain in the butt kind of thing, but now it's simple partial derivatives and it's mostly algebra. Thankfully, a lot of stuff in Calculus 3, if you really understood what you were doing in Calculus 1, the ideas scale up. This is not in that category. We didn't do a lot with tangent planes in that category, but like maxima and minima, the next section, what we did in 1 dimension scales up to 2 dimensions. The same thing we did before, we had to find where the derivatives equal 0. Well, now it's where the partial derivatives equal 0. So that's how we go through and we'll find tangent planes using gradients. So let me give you a fun one to try. You guys ready for another?
Yes.
Sir.
I hope this one is not ugly. I think I picked this out of my head. Maybe I should rewrite that a little bit better. There we go. Hopefully you guys have recognized that it's all of them start off with doing 1/2 plus 4z. And then the only thing that really changes is what happens in here. You got to do the gradient of x minus, once we get, it's like the chain rule. We're doing the gradient there. So we should be getting, if I leave this factor out, so I only calculate it once. One, -3, and 4.
Yeah.
So if I stick in 0, -3, and 0, I've got, so at 0, -3, 0. I've got 1/2 square root of 9. I can make that a little bit shorter. get this all on one line. And square root of 9, we're not going to leave like that because we know what the square root of 9 is. It's 3. 3 times 2 is 6. This is 1/6. So we've got 1/6. Negative 3/6 is negative 1/2. And 4/6 would be 2/3. So that's the gradient of f at P. So we're going to take that and we're going to dot it with x minus x naught, y minus y naught, z minus z naught. And that is a 0, a negative 3, and a 0. So we've got 1/6, negative 1/2, 2/3 dotted with x, y plus 3, and z. And again, that's got to equal 0. Did I take that last thing down too fast? Because
No, I
Benjamin
just
took
heard-
shared it on Discord. I think I might have gone too fast. I can
Oh, no,
put it
that
back
was
up.
me. No, that was me that took that put that on there.
Oh. Did I say? You're right, you did. So what do we have when we do that?
That's why we're here. That's just the formula that I got.
Now, I don't like having these fractions, so I'm going to get rid of them. In fact, I'm going to go back to putting this as 3/6. And I'm going to go back to putting this as 4/6, the unsimplified form. Because then it's a little bit easier to see. I should do that up here. 1/6, negative 3/6, and 4/6. Because then it's a little bit easier to see that if I multiply both sides, everything through by 6, I can at least get rid of the fractions because I'm a firm believer in fuck fractions. Who needs them? Get rid of them when we can. Ta-da!
Whoa, it's magic. Oh, math. Now calculate the direct trajectory of a pigeon coming out of a magic hat.
What? That's some bizarre shit right there.
Well, you said to die. It was a magic trick.
Right?
Well, I was wondering, on the video, you put this formula up, I kind of copied it, and I have no idea what's on it. It's the gradient dotted with R prime of T naught.
Right, and that's what this is.
I think it's that. I think it's that.
That's what that is. So R prime of T naught is that X minus X naught, all that shit.
Yeah. Let's go. Well, let me do that when everybody's done with this. I'll show you where that.
Look at your carbon emissions.
Because I had that and I was like, kind of like confused where the R prime, like what R, like where's R? I was going on with that.
You barely breathe.
I don't want to tell you guys the wrong way. Go on and say whatever. Get it real quick. Get ahead of myself. Let me get back to you on the R prime of T naught. I don't want to fuck up the explanation for you. Clearly, I didn't do it well enough. And we'll talk about it tomorrow morning.
That's all right. You said you're gonna stay at Starbucks all day on Saturday and Sunday, right?
That's true. I will be there. Not all day though. Crackhead shit is that.
Some point you like weekends.
Yeah, we just get all jacked up on coffee and just hang out all day talking about math. Sounds like a good day.
It's like, I'd love to do that.
You know, how many hours do you work? No, this weekend. No, we still eat. Oh, so you're working.
Sure.
Are you liking some whatever? We're getting used to it, right?
All right, you guys ready for another?
I was just thinking about your extracurriculars activities. You get used to it.
Oh, yeah.
Stressing.
So here we've got Z as a function of X and Y.
Yeah.
When you're having something like this and you're trying to switch to level surfaces, you want to rewrite this as Z minus F of XY equals 0. So we'll use our function will now be in terms of 3 variables, Z minus 3x squared Y plus 4xy cubed. So that's what you do when you start off with Z as a function of F of XY. To shift it to finding where we can do this tangent plane thing,
Hey, Mr. Jones.
That's me
Would
all
you
day
like-
long.
Oh, never mind. He already got to it. I was gonna ask to mute Alex. He's been having sound in his background for a while. And it's kind of distracting the students.
You want me to
Oh,
give him a
no.
nap? Give Alex a nap. No?
Do it.
Do it. You heard him.
Confirmation.
I think Trent's lucky I can't turn his camera on. We'd see him asleep again.
I lost my glasses. I'm just looking for them.
Oh, all right.
Okay. Okay. Jesus, I like 30 minutes.
She lost her spirit too, though. Or you just don't have a spirit.
Did that right?
Yeah, I got the same thing.
It's like, looks right to me. And now we'll evaluate at 214. So this is 2 and 1 is -12 plus 4. I've got another -12. Look at that. Plus 24 and a 1. So my gradient of f at p is -8, 12, and 1. And we're doing that with x minus 2, y minus 1, and z minus 4.
And I see that. I think it just means that the normal vector instead of pointing one way, it's just pointing the other way. It's going to give you essentially the same answer. You'll just have like a flip answer because the normal vector you found is going one way and it's going the opposite. But I can go ahead and check, double check with them. It's like, it doesn't matter or not, is it not?
Wow. An equation where we got the right side equals 0. I made that problem up right now. How about that? Pure chance that I end up with a 0.
Hashtag calculated. So, Mr. Jones, if they were to
Exactly.
instead subtract the z onto the other side instead of the f of x y onto the side of z, would that would give the same answer, right?
That would give you this.
Yeah. Which is just having the
Which is
normal
the
vector
same
going.
thing multiplied by -1.
Yeah.
Yeah. So you will result in the same tangent plane.
When we do the parametric, it's gonna be totally different. The parametric equations? Yeah. Imagine the T from positive or negative is pointing in different directions. It's just depending on whether the parametrics are pointing up the plane or down the plane. Right. You're still gonna have the same, you're gonna still have parametric equations on that plane according to from that point. I mean, as long as it doesn't matter.
So I guess that's fine. Yeah.
Ready for another?
Yeah. Let's see, ready for the exam. What? It just takes me so long to write the problem down. I never get to that. You guys know what's the name? And you have a better understanding. I have an idea, guys. We've been even finding the parametric equation. Yeah. I don't have it. I don't have the parametric equation. Well, I only have a whatever this is. I don't even know. A right there. Yeah, me too. Is this the parametric equation?
Your parametric equation probably take the point and you got the gradient at that point, and then you find out you get that like this.
X is equal to
X is equal to X naught plus AT, Y is equal to Y naught plus B, and then T is equal to Z.
So the idea here is that this is surface F and this is surface G.
Where you see
these points?
Yes, the point angle you have.
And they intersect along some line here. We can find the tangent vector at a point there as the gradient of f cross the gradient of g. At P for both of them. We can find the tangent line doing that. Once we have the tangent line, we just parameterize it. So we have z minus x squared plus minus y squared equals 0. So the gradient, if I call that f, gradient of f is negative 2x, negative 2y, and 1.
So I always.
The gradient of g, maybe I'll give myself a little bit of space. Gradient of g is 2x, 8y, and y, and 2z. And so if we evaluate those at those points, we have negative 2, 2, 1. And I've got 2, negative 8, 4. So my tangent line will have components in the cross product. I got 8 plus 8 in the I hat. And then I do minus the j would be negative 8 minus 2 j hat. And then plus the k hat is 16 minus 4. So I've got 16. That's negative 10, so positive 10, 12. So now to do the parametric equations, this is that's the tangent line there. So remember we have x equals x naught plus at. Those where t is a, b, c. And my initial point was 1, negative 1, and 2. I'm bringing that down from above. So I've got 1 plus 16t. Y equals negative 1 plus 10t. And z equals 2 plus 12t. So this is the parametric equations for the tangent line to the curve of intersection of f and g at T. Bless you.
cross product creates a vector.
Why not create a vector, something like?
Oh, what does it do? It creates a normal vector through both of the planes where they intersect.
Yeah, so if we have that, like, maybe I should try to draw this picture a little bit better up here. So we've got some plane like that, and it's intersecting some plane right here. The intersection, like where they cross, is right here. Maybe it's a little more curvy. And we've got some point P. And we're looking for the line tangent to that curve there. And to answer your question earlier, Lawrence, I thought about it. I have an answer I like. So we had R of T is do I like it now?
We can come back to it.
Yeah, I'm gonna come back to it. It sounded better a second ago in my head. I want to make sure I say it right the first time. Put that back up. We'll talk about it tomorrow. We'll lead with it. And have a good day, you guys.
Hey, you too, Professor Jones. Have a solid day.
I will, after my puppy torments me for a while.
Yeah.
He's a domestic terrorist.
But Jericho, does that make sense? Stuff? Why?
You got a puppy?
Yeah.
I guess.
Oh,
better be
nice.
terrorized than have a boring
Yeah.
life.
Yeah, that'll
He's,
be a few sleepless nights.
He's
Cheers, Jones.
right. Where did he go? There he is. If you're still in the room, Zach.
Oh, yeah. You. Yeah, you can tell he has a personality on it.
Yeah. Oh yeah.
Professor.
I'll see you guys tomorrow.
Yeah, good. See you tomorrow.
Signing off.
Peace.
See ya.